So in previous classes, we have learned about the um, register transfer logic, starting with the inter-register transfer. So main purpose is like we will be implementing the digital system, and this digital system will be represented or will be a form of components such as set of registers and some information in the form of binary coded that is stored inside the register, and some operations that is being performed on the information that is stored inside the register. And again, these operations, it will be performed only if the control function, if it is being satisfied. So based on the control function, what all are the operations that is being performed, these together helps in the operation of any digital system. Now what we have learned is how the different individual components it works. So we have learned about the registers and how the transfer of information is possible within the registers, and a diagram also we have seen, that is the inter-register transfer logic. And when we learned about that, we have seen another one case as if a control function is there which is in which a colon symbol is included, and if a colon function is there means it means a control function is specified just before that colon function. So that control function, once it is satisfied, the right hand side, that is after the column function, what is the operation that is or the micro operation that is being specified, that operation will be performed. So we have started with the considering a single control function in which a transfer of data from one register to the other is being done. And then the second example what we have learned was in which two timing variables were considered, or two control functions were considered, and for that two control functions two different operations were being performed, and altogether that example, what does that specify means, more than two source registers will be there. From those two source registers, how the transfer will be performed. That is, in one time variable T1, content of A will be transferred to content of C, and another time variable T5, content of B will be transferred to content of C. So the source registers were A and B, and target register was C. So from the two registers, which source register will be chosen, that is being decided by whom? The multiplexer. So that is what we have seen in the previous class, how that transfer is being done making use of the multiplexer. Then then after that we have seen some symbols that is being used in the register transfer logic, and we move to the next part, that is very necessary during the inter-register transfer, that is the bus. So bus plays a vital role in transfer of any information between the registers. So so the bus structure we have seen, like it will be having some set of common lines, and one for each bit of register, through which binary information will be transferred one at a time. So based on the number of bits, the number of lines inside the bus, it will be um, decided. Okay, so the number of lines inside the bus will be based on the number of bits of any register. If the register is having 4 bits means the bus will be having 4 lines. Then control signals determines which register is selected by the bus during each particular register transfers, and that can be accomplished with the help of the multiplexers. So multiplexer, as we have seen earlier, it helps in selecting the source register and places that content of the source register on the bus. So this we can see with the help of an example, with the help of the diagram. Like here, there are four multiplexers is being used, and four registers are there, like A, B, C, D. Each register they are having 4 bits, so 4-bit lines also will be there inside the bus. Okay, 4-bit. So 4-bit bus lines. That is, a multiplex output of multiplexer will be placed on the bus, and that bus um, will be having some lines, that is 4 line. And that are the base C then based on the number of bits inside the registers. And multiplexers, if how it is being arranged with the registers is like multiplexer, we can say that this is 0, 1, 2, 3. These are the multiplexers, and it is arranged in such a way that the register A 0 bit will be connected to the multiplexer 0, and register B 0 bit will be connected to the multiplexer 0, that is a um, that is the one here, it will be connected. Just see, register B 0 bit of register B will be connected to this multiplexer 0, and again C, from register C also the 0 bit will be connected to the multiplexer 0. From register D also the 0 bit will be connected to the register multiplexer 0. So what does that mean? The multiplexer 0, it combines the 0 bits of all the registers. Okay, ABCD, from ABCD registers, the 0 bits will be combined together to the multiplexer 0. Then what will be the case with the multiplexer 1? Multiplexer 1 will be combining the 1 bit of all the registers. Similar is the case with multiplexer 3 and multiplexer multiplexer 3 and multiplexer 2. So multiplexer 2 will be taking the second bit of all the registers, and multiplexer 3 will be taking all the 4 bit of all the registers. In this way the arrangement is being done in the multiplexer. Then this S1 and S2 will be some input that is given to all the multiplexers, which helps in choosing the source register from the given 4 registers. So since there is 4 registers, the bit notation that will be used will be like 2-bit numbers will be used, like 0, 0, 0, 1, 1, 0, 1, 1, where 0, 0 will be A, representing A, 0, 1 B, 1, 0 C, and 1, 1 will be D. Okay, so based on if S1 and S2 it is giving like a input given is like a 0, 0 means it will be initiating the register, that is it will be initiating the multiplexers to collect the value from the register A. Okay, it will be initiating the multiplexer to collect the bits from the register A. So a 0 bit will be there in the multiplexer 0, a 1 bit will be there in multiplexer 1, 2 will be there in multiplexer 3, that is multiplexer 2 will be having the second bit of register A, like that it goes. Okay. Now, if a sequential transfer is being done, means what happens? This much data path will be there. That is, if there is 3 registers, the data paths that will be available will be like 6, R1 to R2, R2 to R1, like that. So in order to reduce the number of data types, data paths, we can group the wires into some representation like that is given over here. Common line, transfer through one common line. Okay, so if in this case, if some transfer is being done from F1 to F3, what happens is the switches that is being used over here will be connected. That is S1 and S4 will be connected. And if it is like a transfer of all the other switches will be left open. And if the data is transferred from F1 to F2 means which all switches will be open, S1 and SY switches will be closed. The rest of the other switches will be open. In this way, you will be able to transfer the data from one register to the another with the help of the bus. So the group of wires in which a binary information is transferred one at a time among registers is called as a bus. And for parallel transfer, the number of lines in the bus will be equal to the number of bits in the registers that we have seen earlier for parallel transfer. Now we can see this diagram. There is a 4 registers are there, and some how the transfer is being done in the bus to the bus with the help of a multiplexer. So here a decoder is being used, and decoder helps in selecting the target register. Decoder will be used to select the target register. That is, it helps in placing the data to some destination register. So the destination register can be chosen with the help of the decoder. So source register can be chosen with the help of multiplexer, and destination register to which the target value need to be loaded, it can be decided with the help of the destination decoder. So here registers, it is having the bits A1 to AN, A1 AN, which here what it represents is low order bits and high order bits like that. So B, C and D. Similar arrangement is there. So 4 registers are there, and 2 multiplexers is being used over here. And here again 4x1 multiplexer, in which A1 will be connected to A1, that is the 1 bit of all the 4 registers will be connected to the multiplexer. This, let it be multiplexer 0 and this be multiplexer 1. So to this multiplexer the 1 bit will be connected, and to this multiplexer the n bit will be connected to the second multiplexer. Okay, so based on the number of bits the multiplexer will be chosen. Number of registers the multiplexer 4x1 it is being taken. What does that mean? From these 4 registers we need to choose one register, and the output will be like only 1. Okay, so 4 registers, 4 input and 1 output. Multiplexes the information from the 4 registers and gives the single output, and that output where it is being given, that output will be given to given to all the registers. Okay, not all the registers, it is being connected to all the registers. Okay, that output line from the multiplexer, it is being connected to all the registers, and based on the select signal that is connected, that is initiated in the multiplexer. It helps in choosing the register. And what